Yeah, good morning to one and all. This is Nagajyoti working as an assistant professor in Department of ECE in St. Peter's Engineering College. So today in this session, I want to discuss the course of Digital System Design of Unit 2. So in case of a Unit 1, we have studied about what are the different types of number systems, how to convert from one number system towards the other number system, what is meant by complements, how to perform a subtraction using the complements, classification of codes, and what is the importance of each and every individual code, and how to perform error detection and correction using a Hamming code and a parity code. And the second part of Unit 1 deals with the Boolean algebra. What are the basic theorems and laws which are used in the Boolean algebra, and what are the different forms of an equation of a Boolean algebra, that is SOP as well as POS, and how to convert a simple SOP and simple POS into a standard form or a canonical form. Similarly, which gates, what are the basic gates, what are the different types of gates, and which gates are called as the universal gates, and why we can say only those gates as an universal gates. So NAND and NOR gates are called as a universal gates, and we have seen that how to realize the given expression by using only the NAND gate and by using only the NOR gate. So the complete second unit deals with two parts, that is unit 2 deals with two different parts. The first one is Boolean algebra simplification, Boolean algebra simplification using K-map, and the second part is deals with combinational circuits. So here today in this session, let us discuss what is the different method other than using laws and theorems, how to simplify the given Boolean expressions. Now let me take a simple example. So algebraic simplification, algebraic simplification can be done by using two different methods. That is, the first method is by using Boolean laws and theorems, and the second method is by using a concept of K-map. So here, in order to simplify any Boolean expression by using Boolean laws and theorems, we need to remember all the laws and theorems. If we are unable to remember those laws and theorems, we cannot minimize the given Boolean expression to minimum number of literals and variables. But whereas in case of a K-map, without using any laws and theorems, we can directly simplify the expression. So here, let us see the algebraic simplification using Boolean laws as well as the K-map. Now let me take, I am taking an example of A bar B bar plus A bar B. So I want to simplify this expression. So this expression consists of two variables. So here those two variables are A and B. Similarly, it consists of it consists of three literals, that is A bar, B, B bar. So if I want to draw the circuit diagram for this gate, for this expression, I want to use a NOT gate. The input is A, output is A bar. Similarly, for B bar, I need to use other more NOT gate. So the output is B bar. As these two are connected in a dot, which is nothing but I need to use an AND gate. So the output of an AND gate is A bar dot B bar. Similarly, the second term is A bar. So here I need to use A followed by A bar, or you can connect directly from A bar. Similarly, B, again these two should be connected with an AND gate which is equivalent to A bar B, and these two are connected with a plus symbol, that is OR symbol. So this is a logical diagram for the given expression. So in this one, if I observe this, I need to use NOT gate for A bar, NOT gate for B bar. If I am using the same gate, I can take this gate into the same consideration. So this is the third gate, fourth gate, and the fifth gate. So in order to draw the logic diagram for this A bar, B bar plus A bar B, I need of total 5 gates. But if I am simplifying the expression, now let me take, I am going to simplify these expression by using Boolean laws and theorems. So in this case, in the first two cases, A bar is common. So I am taking A bar as common. So the leftover is B bar plus B. So according to the Boolean law, we have seen that B bar plus B is equivalent to 1. Because if you take B equal to 0, B bar will be 1. 0 plus 1 is 1. If B is 1, B bar will be 0. 1 plus 0 is 1. So B bar plus B is equivalent to 1. So A bar into 1, which is equivalent to A bar. So if I want to draw the logic diagram for this simplified expression, I need of only one gate, that is NOT gate. So output is equivalent to A bar. So if I compare the first one with the second one, before simplification I need of 5 gates, but after simplification I need of only a single gate. So here the power consumption required in order to build this corresponding expression is less after simplification. So the use of these algebraic simplification is the memories, that is in case of a designing it will take less number of gates. If the number of gates are reduced, the power consumption required for the circuit also reduces. And the second more important thing is, if the number of gates are less, the space required in designing of an IC is also less. That automatically reflects the cost of the circuit is going to be reduced. So the main advantage of going for the algebraic simplification is number of gates are going to be reduced, power consumption is going to be reduced, so automatically the cost of the circuit is going to be reduced. Now, if I am unable to remember this B bar plus B is equivalent to 1 and 1 into A bar is equivalent to A bar, we cannot simplify this process without the laws and theorems. If we are unable to remember the laws and theorems, it is difficult to simplify the expression of the given Boolean thing. So here what I am doing over here is, I am going for the second more concept called as K-map. So here K-map is nothing but a Karnaugh map. So here K stands for Karnaugh map. So in case of a Karnaugh map, we are not going to use any laws and theorems of a Boolean algebra. Just we are drawing the K map. From that K map, directly we are going to simplify the expression. So this is the basic drawback of the algebraic simplification by using laws and theorems is, we need to remember all the 20 laws and theorems of the Boolean algebra. Then only we can able to reduce a given minimum expression. We can able to reduce the expression to a minimum number of variables as well as literals. But without using the laws and theorems, if we want to reduce the Boolean expression, the concept which we are using is a Karnaugh map. So in case of a Karnaugh map, as we have seen that in case of a classification of codes, there are different types of codes. One is weighted code and the other one is non-weighted code. Similarly, under the weighted code, we are having binary as well as BCD. Under the non-weighted code, we are having gray code, XS3 code. So here, in case of a Karnaugh map, we'll be using a gray code in order to simplify our expression. So here the K map uses the type of code which is nothing but gray code. Why we are using only the gray code in case of a corner of map is, see here, in this example, whenever I am doing a process of simplification, I am taking a common term which is variable which is common for both the min terms. So here, as we know that gray code is also called as unit distance code, as well as it is called as mirror image code or self complementing code. As it is performing a mirror image operation, this is basically used in case of a k-map, because whenever we are writing the gray code for 0 to 7 numbers, there will be a change in the single bit position if we take any two consecutive numbers of a gray code. So here, as gray code is having a property of unit distance code, this gray code is used in the simplification of Boolean algebra using a K-map method. So now let us see the K-map method for this given Boolean expression. So whenever I am performing the K-map method for this Boolean expression, I need to check how many number of variables are there in the given expression. So here the given expression is consisting of only two variables, that is A and B. And the other more important thing is, whenever we are drawing the K-map, we are need to consider only the variables but not the literals. So here in the previous example, whatever the example which we have taken, the variables are only the A and B. So here I need to draw the two variable K-map. So depending upon the number of variables present in the expression, we need to draw that many number of variable K-map. So in this case, now let me take an example of, first is two variable K-map. So in case of a two variable K-map, whatever may be the K-map which we are considering, if the K-map is having n variables, it consists of 2 power n cells. So as I am saying it as two variable K-map. So here two variable K-map itself indicates here n value is 2. So 2 power 2, which is nothing but 4. So in case of a two variable K-map, it consists of 4 cells. So here this is a two variable K-map. This is A, this is B. So here first variable is A, second variable is B. So under the variable, if there is single variable, we will be getting two different combinations. Those two different combinations are 0, 1. Similarly, for B variable also we will be getting two different combinations, that is 0, 1. Now we need to check the row followed by column. So the first is row, or in simple words I can represent this as A bar, this as A. This complete row is A bar row, this complete row is A row. Similarly, this column is B bar, this column is B. So A bar, B bar. So this first cell is related to a term called as A bar, B bar. Or if I want to write down the same thing in terms of the min terms, that is as it is 0, 0, this cell is corresponding to the min term 0. Similarly, the second cell represents first is row A bar, column is B. So the corresponding min term is 0, 1, which is nothing but M1. Similarly, the third one is A followed by B bar. A followed by B bar. 1 followed by 0 is nothing but 2. This is the second min term. And the last cell is A, B. 1, 1. So 1, 1 equivalent in decimal is 3. So the min term is 3. So this is how to draw the two variable K-map and how to plot the corresponding min terms in a two variable K-map. Similarly, if I am going for a three variable K-map, so in case of a three variable K-map, I will be having 2 power 3 cells, which is nothing but 8 cells. So in case of an 8 cells, let me take those three variables are A, B and C. So whenever I am taking A, B and C, I need to draw the K-map in such a way that which consists of 8 cells. This corresponding is A. This is related to BC. And under A variable we will be getting only two combinations. One is 0 and the other is 1. Under the BC we will be getting four combinations, that is 0 0 0 1 1 0 1 1. Here we should not write down 1 0 over here, because whenever we are here, the sequence which I am writing is a gray code sequence. I will tell you one example. Now let me take, I am writing the numbers from 0 to 7. That is three variable numbers. So here I am performing the gray operation. These are binary. I want to convert this binary to gray. So whenever we are performing binary to gray, the first MSB bit I will be writing as it is. The second bit is I am performing the XOR operation between first and second. So 0 XOR 0 is 0. 0 XOR 0 is 0. Similarly, first bit is 0. 0 XOR 0 is 0. 0 XOR 1 is 1. 0 MSB is as it is. 0 XOR 1 is 1. 1 XOR 0 is also 1. First MSB bit as it is. 0 XOR 1. 1. 1 XOR 1. 0. First MSB bit 1. 1 XOR 0. 1. 0 XOR 0. 0. Next MSB bit is 1. 1 XOR 0. 1. 0 XOR 1. 1. Similarly, 1. 1 XOR 1. 0. 1 XOR 0. 1. MSB bit is 1. 1 XOR 1. 0. 1 XOR 1. 0. So, for the binary digit 0, for the binary equivalent 0, the gray code is also 0. For 1, gray code is 1. But for 2, the gray code is 3. So that is the reason, if you observe here, 0 0 0. So this is M0. 0 0 1. This is M1. So for 0 it is 0, for 1 it is 1. But for 2 it is 3. So 0 double 1. So it is 3. That is the reason whatever the sequence which we are writing on the K-map is a gray code sequence. Because if you take any two consecutive numbers of a gray code, there will be change only in the single bit position. That is the reason gray code is also called as a unit distance code. So as it is having a property of a unit distance property, the same thing which we are using over here. So under the BC we need to write down 0 0 0 1 1 1 1 0. So M0, M1, 0 double 1 is 3, 0 1 0 is 2. So here in other way I can write down here, this is A bar, B bar, C. This is A bar, B bar, C. This is A bar, B, C. This is A bar, B, C bar. Similarly, 1 double 0, 4, 1 0 1, 5, 1 1 1, 7. This is 6. If you want to write down in terms of the midterms, this is A, B bar, C bar, A, B bar, C, A, B, C, A, B, C bar. This is how to plot a gray code for a 3 variable Boolean expression, or it is a 3 variable K-map. Similarly, if I want to draw for the 4 variable, so in case of a 4 variable K-map, it consists of 2 power 4, which is equivalent to 16 cells. So the total number of cells in a 4 variable K-map are 16. So here those 4 variables here I am representing in such a way that AB is one side and CD is the other side. This complete deals with AB and this deals with CD. As we have written for 2 variables, the same combination we need to write down: 0 0 0 1 1 1 1 0. 0 0 0 1 1 1 1 0. Similarly, if we want to plot the corresponding midterms of the 4 variable, 0 0 0 0, which is nothing but M0 0 0 0 1, M1 double 0 double 1, M3, or in simple I can say that 0 1 2 3. Similarly, 4 5 6 7. Coming to over here, double one double zero is equivalent to 12. So here this is 12. So 0, 1, 2, 3, 4, 5, 6, 7. 1 triple 0 is 8. So this is 8, 9, 10, 11. This is 12, 13. This will become 14 and this is a 15. So here this is how to plot a 4 variable K-map. This is all about plotting of a K-map. So in case of a simplification of a Boolean expression using the K-map, we need to have two steps. The first step is, first we need to plot the K-map. Then we need to write down the corresponding min terms in the K-map. That is plotting of the, first is drawing of the K-map. Second is plotting of the K-map. And the third one is, we need to see which cells are adjacent cells. So here what is meant by adjacency is, whenever we are, let me take, this is a two variable K map. If I am folding this K map over here, can I say this M1 is overlapping on the M0? In simple words, I can say that two cells are said to be adjacent if the two cells are side by side. That is the one way. And the other way is, if there is change in the single bit position of the two cells, then those two cells are called as an adjacency cells. Now, let me take an example. So, let me assume that this is a K map. So, in this K map, if I am folding this K map, let me take, this is a two variable K map. This is one cell, second cell, third cell and fourth cell. If I am folding this K map in the horizontal way, this first cell will be overlapping on the second cell. So these two cells are said to be adjacent. Similarly, if you are folding the K map in the vertical, that is in the vertical, in this way, you can say that these first two cells will be overlapped on the third and fourth cell. So here we can say the adjacency in such a way that if there is change in the single bit position of the two cells, then those two cells are said to be an adjacent cells. So whenever we are grouping the only two cells, then such a pair is called as an adjacency. Similarly, if you are grouping four cells, then such a combination is called as a quad. And the other more important thing is, in case of a K-map simplification, we need to combine the cells only in the powers of 2. That is, either you can combine 2, 2, 4, 8 or 16. We are unable to combine the cells as 6, 10, 12. Always the combination, that is adjacencies, in whether it may be combining of 2 cells or 4 cells or 8 cells or 16 cells. So combining of 2 cells is called as an adjacency. Combining of 4 cells is called as an quad. Similarly, combining of an 8 cells is called as an octet. So now let me take the example which we have taken previously, that is A bar B bar plus A bar B. So here in this, I don't want to use any laws and theorems, but I want to simplify the Boolean expression by using the K-map. So in this simplification, as it consists of only the two variables, those two variables are A and B. So I need to draw a two variable K-map. So here two variable K-map consists of four cells A, B. This is 0, 1, 0, 1. And this is the first step, that is a drawing of a K-map. And the second step is, from the expression, we need to write down the corresponding in terms of the midterms. So here, as the expression is an SOP expression, so when we can say that particular expression is an SOP expression, if it is having a product term followed by OR together. So as I am having A bar dot B bar plus A bar B, as the first terms are product followed by OR, then it is called as an SOP expression. So in case of an SOP expression, if the corresponding variable is having with a complemented form, that is treated as 0. If it is in the uncomplemented form, it is treated as 1. And the other more important thing is, whatever the minterms which they have given, that should be written in an order. Now let me take first we have written it as B then followed by A. We should not write down in that way because always it should be in an order so that whatever the minterms which we are getting is a correct type of a minterm. So here A bar, as it is an A bar, I am representing it as 0. Similarly, it is B bar 0. So 0, 0 is nothing but equivalent of 0. Similarly, as it is A bar, again it is 0. As it is B, it is 1. So the 0, 1 equivalent in case of a decimal is 1. So the for the corresponding expression A bar, B bar plus A bar B, the SOP expression or in terms of a minterms, I can written it as sigma m of 0 comma 1. So I am having two minterms, one is m0 and the other one is m1. So here as it is an m0 cell, this is m1, this is m2, this is m3. Whatever the numbers which we got from the expression, just keep a ones. As it is an SOP expression, I am keeping a ones. If it is a POS expression, instead of keeping ones, we need to place it as zeros. So here as it is an SOP expression, under M0 I am keeping it as 1. Under M1 also I am keeping it as 1. And remaining don't write anything. Now this is a plotting of K-map. So from the given expression, if the expression is in the terms of the variables, convert that into the sigma m or pi m terms. That is either it may be a SOP or a POS expression. So whatever the variables, whatever the minterms which we got from that expression, plot those numbers in the K-map. As just now we have discussed that these two cells are said to be adjacent cells. Just combine these two cells. Just join these two cells. Now for these corresponding, we need to write down an expression. So in order to write down the expression for these two cells as it is having in the common row. So here the row is nothing but 0. For this 0, the corresponding variable is A. So here it is A bar. First, whenever we are combining, first see the row part followed by the column part. So the row part is as it is present only in the single row. The corresponding row is 0 and this 0 is related to A. That is the reason here I am writing it as A bar. After completion of row, check for columns. So in the columns, as the ones are present in both the columns, for the first column the corresponding is 0, for the second column the corresponding is 1. Or I can say this is B bar, this is B. When both are opposite to each other, both will be cancelled out. 0 and 1 will be cancelled out. So the leftover equation is only the A bar. Even if you perform the simplification operation by using the laws and theorems, the result, whatever the result which we got is only the A bar. So in this, I am not going to use any laws and theorems, just I am drawing that K-map, plotting the ones or zeros in the K-map depending upon the expression is either the SOP expression or POS expression. Then I am checking whether this is related towards the adjacency of which cells. So in case of an adjacency, whichever the cells are same, I will be writing the expression. Whichever the cells are in the opposite, just opposite cells will be cancelled out. So the leftover expression is A bar. Similarly, let me take an example for the three variable K-map. Or in the same example, let me take, I am having the other more expression for this is A bar, B bar. So sorry, A bar, AB. So if it is AB, the corresponding terms are 1 and 1. So here 1 1 represents there is other more minterm which is nothing but 3. So I need to keep 1 in the M3. Now these two cells are joined. Again, if I am superimposing this towards the downwards, these two cells are said to be adjacent cells. So if I am writing the result for these first adjacency, I will be getting it as A bar. Similarly, if I am writing the adjacency for these two cells, as these two cells are related to two rows, that is first row is 0, second row is 1, both will be cancelled out. As it is present in a single column, that corresponding column value is 1. This 1 is related to B. So, the simplified expression for these adjacency is B. So now overall expression is A bar plus B. So write down the combination separately. Then as it is an SOP expression, product followed by sum. That is product term should be OR together. So by combination of first adjacency I will be getting A bar. By combination of second adjacency I will be getting B. Just perform an OR operation between those results which we got. So this is the result for this expression. So the only thing is, similarly, let me assume that there is an expression as A B bar. So the question is A bar B bar plus A bar B plus AB plus AB bar. So A B bar, A is 1, B bar is 0. So the corresponding term is 2. So here I need to write down 1. So now whenever we are having 4 ones, so here 4 ones itself indicates no need to perform the adjacency. So here if you are performing the adjacency, this you can make it as 1 adjacent, this you can make it as adjacent, will be getting 4 adjacencies. Instead of making use of 4 adjacencies, you can make it as 1 quad. Always whenever we are performing the simplification, first check more number of adjacencies. Rather than making use of 2 cells as adjacent cells, first check for higher number. So if I am using a 4 variable k-map, first check is there any adjacencies of all the 16 cells. If 16 cells are not possible, then go for 8 cells. If 8 is also not possible, then go for 4. If 4 is not possible, then go for 2. So always whenever we want to perform the simplification operation, first check for the higher adjacencies rather than checking for the lower adjacencies. So if I am combining all these cells as I am making grouping of 4 cells, this grouping of 4 cells is called as an quad. So as it is having 2 rows and 2 columns, this 0 1 will be cancelled out, so A will be cancelled out. Similarly, as it is having 2 columns, one is 0 and the other is 1, these two will also be cancelled out, so the resultant is equivalent to 1. So as it is a 2 variable k-map, as all the cells in the 2 variable k-map are grouped into a quad, the resultant is equivalent to 1. So this is how to perform the simplification operation using the k-map method. Similarly, let me check how to perform the simplification operation now for the 3 variable. Now till now we have discussed how to perform the simplification operation for a 2 variable k-map. Now let me take, I am doing the simplification operation for the 3 variable k-map. So in case of a 3 variable k-map, let me take the expression is AC plus C into A bar plus B. This I want to, C into A plus C into A plus A bar B. This I want to perform the simplification operation by using the k-map method. So here, as if we observe this expression, it consists of 3 variables. One is A, second is B, third one is C. So the first step is, first expand this, that is AC plus AC plus A bar B. A bar B into C. Now, if we observe this, this is having a minterm of only a 2 variable. Here also I am having a minterm of only 2 variable. Here I am having a minterm of 3 variable. So whatever the expression which we have written, it is a simple SOP. So here AC plus AC is nothing but A plus A is A, so we can write down AC plus AC is equivalent to AC. Or in the other words, we can say that we can do this plotting of k-map in 2 different methods. The first one is, first we are converting this simple SOP into a standard SOP. So or into a canonical SOP. So whenever we are performing a simple SOP into a standard or a canonical SOP, so in the first, now I am taking as it is AC plus AC, just I am writing this is a single AC and left over with A bar BC. Now, in this case, in the first midterm, B is missing. So, I will be writing AC into missing term. That is, I am converting a simple SOP into a standard SOP or a canonical SOP. So, whichever the term is missing, just multiply that term with the complemented as well as an uncomplemented form. Plus A bar BC. So, here write down in a sequence, that is A, B, C plus A B bar C plus A bar B C. Now, if we observe each and every individual minterm, this minterm is covering all the variables of a given term. So, here as it is A, B, C, all are in the uncomplemented form. So, I am writing an expression of sigma m of 1, 1, 1, which is nothing but 7. Similarly, A is 1, B bar is 0, C is 1. So 1, 0, 1, that is 5. If you are unable to get this 1, 0, 1 as 5, just multiply from the LSB with 2 power 0, 2 power 1, 2 square. 2 power 0 is 1. 1 into 1 is 1. This is 2 power 1. This is 2 square. 2 square is 4. So 4 plus 1 is 5. Similarly, A bar is 0, B is 1, C is 1. So 0 double and 1 equivalent is 3. So I can write down in an adder sigma of 3, 5, 7. This is the one way how to write down the given expression in terms of a sigma m form, or in the other form we can do it directly. Now I can draw the K map for the three variable. This is A, B, C, 0, 0, 0, 1, 1, 1, 1, 0. This is 0, this is 1. As we know that this is M0, M1, M3, M2, 4, 5, 7, 6. So the given numbers are 3, 5, 7. So the given expression is having three midterms. One is 3, 5 and 7. Or the other way which I can do over here is I can directly draw the K map from the expression itself. This is A, this is BC, 0, 0, 0, 1, 1, 1, 1, 0, this is 0 and 1. So the first thing is we need to expand this and we need to do till this point. Now coming to this, here first check whichever the midterms is covering all the variables. So here this midterm is covering all the variables. Here A bar is, or in simple words as it is A bar. The first row is related towards the A bar and it is BC. So here 1, 1 represents BC. So see whichever the line is intersection of row as well as column. As it is A bar, this is an A bar. So the first row and it is BC. BC is related to third column. So the intersection point of first row and the third column is this cell. So this cell represents A bar BC. So here I am plotting a 1 at the A bar BC. Similarly, if you observe here, one is A. A represents this bottom row because under A I am having a 1. Similarly, B is missing but I am having a variable of C. C represents the last bit. So whenever I am saying it as a C, the corresponding bit should be equivalent to 1. Check where you are having 1. So here I am having 1. Here also I am having 1. So here this second column and third column will reflect C, and as I am not having B bar, I can take any values of the choice of the B bar. So only check whichever the variable is present. So here first variable is A. So A is related towards the bottom row and C is related to second column and third column. So we can directly put the ones in the corresponding. Either you can convert the simple SOP into the standard SOP, or you, depending upon the given expression, you can, if you are able to plot it directly, you can directly plot the K maps. Then the last step over here is we need to perform the simplification. So if I observe, if I am folding this K map towards the down, I can say that these two cells are adjacent cells. So if I am combining these two cells, as these two cells are present for two different rows, this 0 and 1 will be cancelled out. So there is no variable related to A. It is having a single column. That single column is 1 1. The first one is related to B, second one is related to C. So the corresponding minimized expression for this adjacency is BC. Similarly, if I am combining these two, it is in the single row, that row is related to 1, this one is related to corresponding variable A, so it is A. Once you have written with row, you need to check for the column. As it is present in the two columns, the corresponding numbers related to these columns are 0, 1 and 1, 1. Whichever the number which is opposite, that will be cancelled out. Whatever the number which is in the same for both the columns is 1. This 1 is related to C. So the expression which will be getting is C. Or in other words, I can say that the expression is AC plus BC, or if you take C as common, you will be writing it as A plus B. Either you can write down in this way or in this way. Both are one and the same. So this is how to simplify the K-map expressions by simplify the Boolean expressions by using a K-map. This is all about a 2 variable as well as 3 variable. Now let me take the minterm, whatever the minterms which I have written is in this way. So here I am having the ones in this way. So here instead of pairing like this, what I need to do over here is I need to make, because as I am having ones at this position, I need to make this as a quad. After making it as a quad, two are left over. This one is adjacent. So for this quad, the result is this quad is having in two rows. So row will be cancelled out. It is having in two columns. Compare the corresponding numbers which are present in the columns. This is 1 1, this is 1 0. So C variable will be cancelled out, left over with only the B variable. As 1 is present over here, we can make these two as an adjacency. So the result is row is A, columns are C. So it is having a next bit as AC. Similarly, we are left over with this one. If you are folding this K map to this side, this one will be overlapped on this one. So here, as it is in the single row, that is corresponding to A bar, and here it is having two columns, one is 0 0 1 0. So the expression for this is A bar C bar. So the overall expression is AC plus A bar C bar plus B. So this is how to simplify the given Boolean expression by using a K-map without using any law sign theorems.